Unit 3, Lesson 3. This lesson will align with 12.1 in your textbooks. One standard we're going to cover: identify the shapes of two-dimensional cross-sections of three-dimensional objects and identify three-dimensional objects generated by rotations of two-dimensional objects. The definition of a cross-section is a plane intersecting with a three-dimensional object. If we focus on this pyramid over here, so we have the solid pyramid, a three-dimensional object, and then we're taking a plane perpendicular to that, and we're trying to determine, if we say cut this portion off, what would be the two-dimensional shape of the face of that object now. And if you look at this, we'd have a square base. Our two-dimensional cross-section is going to be a square. If we focus on this double cone over here, kind of like an hourglass, there's many different two-dimensional cross-sections that can be created depending on how we slice this. If we go with the most simple way and slice this horizontally, perpendicular to it standing straight up, our cross-section is going to be a circle. If we slice it at an angle so that it goes through both sides of one portion of the cone, it's going to create a two-dimensional object or a cross-section that is an ellipse. Now, an ellipse, the slang term you're used to, is probably an oval. That's what an ellipse is. If we slice one portion of the cone starting at the top, that's going to create a parabola, which we talked about in Algebra 1, the U-shaped graph. And if we slice it so that it goes through both portions of the cone, the top and the bottom, it's going to create what's called a hyperbola. So depending on the angle and where we start our cross-section at, it can create many different shapes. Next, we need to take a two-dimensional shape, rotate it around an axis, and try to determine what three-dimensional object would be created. Alright, so in this first one, we have a quadrilateral. One thing I'm going to focus on is that I notice at the top it comes to a point. So my three-dimensional object is going to have some sort of point that it comes to in the end. So right away I can get rid of this option and this option. And now I notice if I look at the bottom of this quadrilateral, it's flat. So the base of my three-dimensional object should be flat as well. And it's not going to extend. It comes straight up. It does not get wider at the base compared to the body. So I can get rid of the cone, which means this is the three-dimensional object. If we rotate this two-dimensional quadrilateral across line T, we're going to get this three-dimensional object. Again, we're going to take the two-dimensional object, rotate it around the axes, and try to determine the three-dimensional object that is going to be created. Again, we have a quadrilateral. This is actually a trapezoid. We have exactly one pair of parallel sides. The other sides are not parallel, so this is a trapezoid. Again, if I look at the top, it's flat. It does not come to a point. So looking, I know it can't be that one. If I look at the bottom, it does not come to a point. So I know cannot be that object. The other two are very similar. Only difference is one object is wider at the top, the other one's wider at the bottom. If I look, the top of my two-dimensional trapezoid is wider than the bottom. So the top of my three-dimensional object must be wider than the bottom. So it can't be that object. It must be this three-dimensional object. We would rotate this trapezoid around this axis line T. This would be our three-dimensional object that's created. Just to quickly summarize, the focus of this lesson is to visualize. One thing you need to be able to visualize is if I give you a three-dimensional object and I perform a cross-section on that, I slice it a certain way to create a two-dimensional cross-section, you need to be able to determine what two-dimensional shape is going to be created. Or if I give you a two-dimensional object and I tell you I'm going to rotate it about an axis, you need to be able to visualize and determine what three-dimensional shape would be created by that rotation.